This is a video presentation of Chapter 7, Section 7, entitled Choosing an Appropriate Display. Our objective here is to select and use appropriate representations for displaying data. Now, in your math textbook on page 412, the 6 different primary graphs that are discussed in this book and in your 7th grade courses are explained on when is an appropriate time to use each one of those graphs. So I would ask you to reference page 412, as nowhere in the note presentation here that you're about to see does it actually show when to use these different graphs. You want to use a bar graph to display and compare data. And oftentimes you will hear the phrase distinct categories thrown around when they talk about bar graph. Line graph, by comparison, shows how data changes over a period of time. And we discussed that quite a bit when we talked about line graphs in the previous section. You want to use a circle graph to show how a set of data is divided into parts. When something adds up to 100%, that should be a large tip-off that it would be a circle graph. A line plot shows the frequency of values, so if they give you a large just list of numbers to work with necessarily no corresponding information, look for a line plot. It could also be a stem and leaf plot, which shows how often data values occur and how they are distributed. And a Venn diagram shows relationships between 2 or more data sets. You may also see the box and whisker plot presented to you. The box and whisker plot will be a tip-off because they will be talking about 4 even-sized groups or 4 quarters. Remember that phrase, interquartile range, from talking about those plots. The quart, as in quarter part, would be a tip-off there. Also, they don't talk about it much here, but a histogram is also could be thrown up. Usually when they're talking about a histogram, they would probably preference it with a frequency table, because remember the frequency table goes with that graph. Okay, so reference page 412 as you need it, but let's go ahead and take a look at example 1 here. It says the students want to create a display to show each species of butterfly as a percentage of all species in the butterfly family. Which type of graph should they use? And then they ask us to explain. Okay, so one of the key phrases in there is at that middle part of that second sentence when they're talking about it being a percentage of all the species in the butterfly family. And you see percentage there, so that could be a good indicator. Well, let's take a look here. Each listed species is a part of the whole population, so a circle graph will show how a set of data is going to be divided into parts. Parts of a whole, or things that add up to 100%, or even percentages in general, should be a tip-off to you that the graph that's ideal in that situation would be a circle graph. The students want to create a display to show the relationship between the species of butterflies in the park. Choose the type of graph that would best represent the data and explain. In this case, the Venn diagram shows species that do not overlap but are in the butterfly family. Now, we don't really spend any time in the math book talking about a Venn diagram, but you do often talk about Venn diagrams in English and language arts type classes, usually when you're preparing to write a compare and contrast type essay. A Venn diagram, in case you've forgotten, or have forgotten rather, is 2 circles which overlap, or potentially more. One circle representing one item, a second circle representing a second item, and the area in which they overlap is where you put what's in common of those sets of numbers. So, for instance, let's say that the circle on the left, to bring this to the idea of math, represents the even numbers between 1 and 10, and the circle on the right represents the prime numbers between 1 and 10. Well, of course, we know that the even numbers between 1 and 10 are 2, 4, 6, 8, and 10. The prime numbers between 1 and 10 are 2, 3, 5, and 7. In case you've forgotten what a prime number is a number that's divisible only by 1 and itself. So the only way to make 2 is 1 times 2. The only way to make 3 is 1 times 3. The only way to make 5 is 1 times 5. Whereas 6 is not on that list because 6 can be composed of 1 times 6, but also 2 times 3. So, in the middle sector here, where they overlap, you put the numbers that would be on both lists. And as you can see, the only number that's on both lists is 2. So the only thing I'm going to write that these two sets of things have in common is 2. The outside sectors, the parts that are not overlapping, represent the numbers that are simply distinct to those categories. So here's where I would put 4, 6, 8, and 10. Here's where I'm going to put 3, 5, and 7. And there's a mathematical Venn diagram. Now, as I said a moment ago, a Venn diagram can be extended to multiple circles, not just 2. So you could have, for instance, a third circle here that would sketch in like this, where this part of the overlap is between this circle and this circle, so it would list what's in common these two things. This area of overlap would express what's in common between this thing and this thing. This area that we just filled in would only be related to what's in this category and this category. And this smaller segment here overlaps all 3 circles. So it would express what's in common to this, this, and this category. Okay, let's take a look at number 2 here. The table shows the number of visitors to the butterfly park during a 4-month period. Explain why each kind of display below would or would not appropriately represent the data. And the first one that they're asking about is a circle graph. Well, remember, as we talked about earlier, circle graphs usually come into play when something adds up to 100%, or they're talking about it being parts of a whole. And that's indeed what they preface there in the first sentence. A circle graph shows how part of a set of data relates to the whole. Well, nowhere do they represent to us, or present to us rather, that that is all of the data. They just happen to pick those 4 months. So there is being no relationship from the parts to a whole here, so a circle graph would not be appropriate. There might be information for April or March or September that they're not showing us, so it can't be the whole unless they said, for instance, something like it was only open from May to August. Then it would be how many visitors came in each month, being the whole year, for instance, or the whole time the park was open. So a circle graph is not going to be a winner in this scenario. So then they ask about a bar graph. A bar graph generally shows categories of data. Now, a bar graph would be a successful attempt here, because the bar graph, if you call each month its own category, May being its own thing, June being its own thing, July being its own thing, and August having the same property, that would work. Those are each distinct categories, so you can use a bar graph to represent the data. Then they ask about a line plot. Remember, the line plot is the one that shows the number line that we put the X's above to indicate where everything falls. All right, so that's going to show the frequency of data values. Usually you're going to use the line plot when something happens a lot, because remember, that stacked thing of X's represents how many times something occurs. And in this case, every number just shows up one time. So you could use a line plot, but it really doesn't make any sense. And with the numbers being so big, you'd really have to make a very large number line to make that happen. So a line plot would not really be appropriate here. If something occurred many, many, many times in terms of the numbers, and that the numbers repeated on the graph, a line plot that might then make sense. They conclude by asking about a line graph, and as we talked about when we created line graphs in its section, a line graph is the perfect time to represent time. That's what a line graph does, is it shows how data changes over time. And indeed, May, June, July, August is time, So the line graph would compare data over time, and the line graph is appropriate, and in my opinion, probably the most appropriate of all the graphs you could pick. Notice, line graph was not the only answer. Do not limit yourself to just one answer. There are potentially several or many different answers that can work when they ask you about what type of graph you could make from a set of data. Okay. So let's take a look at the check it out examples here. The first question says the students want to create a display to show the total number of roses in the garden and see which ones occurred more frequently. Which type of graph should they use? Notice that I'm underlining the word frequently. They're very specifically referencing they want to know how often something occurred. And even though none of the numbers repeat in the table, they are asking about frequencies. Frequencies always show up with a line plot. Again, that taller bar of x's is always going to represent which one shows up the most often. So indeed, line plot is going to be the winning answer here because it displays total numbers and frequencies. Okay, the table shows the weights of 4 animals at the animal sanctuary. Does the line graph below appropriately represent the same data? And then we are to explain. Well, let's think about what we have here. We have a line graph. And we know about a line graph because a line graph really is only supposed to represent data over time. And if you look at the categories here, it's the names of different animals. Koala, chimpanzee, Sumatran tiger, and male gorilla. It is not May, June, July, August. It is not noon, 1 o'clock, 2 o'clock, 3 o'clock. It really doesn't have anything to do with time. It actually is distinct categories. So this one would probably a little bit better be represented with a bar graph as opposed to a line graph, simply for the fact that it has nothing to do with time.